Hello, everyone. On this occasion, I will explain about my research, automated code readability feedback on student awareness. I'm Oscar Karnalim, and I'm from Maranatha Christian University. I'm with Sendy, Ferdian, Sujadi, and Rossevine, Artha, Nathasya. First of all, the introduction. So, despite its importance in industry, writing readable code is often overlooked in academia. Consequently, several automated checkers dedicated to academia have been developed. However, they cannot be easily integrated to many existing teaching environments. Why? Because first, they either work as standalone applications, they are embedded to specific integrated development applications, or they rely on historical data. So we address the concern by developing an automated checker called CQIS and integrating the checker into an assessment submission system. So each time a program is submitted, a code readability report will be generated and the unique link will be sent to the author. The report highlights parts of the submitted program that can be made clearer, and the author can voluntarily check the report and resubmit the work if needed. Such a mechanism can be applied to many existing teaching environments, given that it does not affect the flow of teaching and completing assessments. And what is our contribution in this study? So this study basically evaluates the checker for 2 academic semesters. Our checker was employed in 6 courses with a total of 222 students. So at the end of each course, we ask the students about their agreement toward 14 code readability aspects for Java and Python. We also ask the students about when they fix the code readability issues during the assessment. Based on 168 responses, we summarize the findings. So this is our survey statistics. So we have 222 students with 168 responses. And these are our survey questions. So basically we have 17 questions. 14 of them are about code readability issues. So how we did the analysis? First, the analysis was conducted at 2 granularity levels, overall and programming levels. Programming levels means CS1, CS2, and advanced. For each analysis, responses of key 01 to key 14 and key 15 were analyzed quantitatively based on their average Likert score. Key 16 will be summarized and discussed to complement key 15 findings. Key 17 was analyzed quantitatively based on the proportion of responses for each option, and any comments from the instructors were considered to explain most of the phenomena. We are also interested in checking whether awareness of code readability was improved on higher programming levels. So we compared average agreement score across programming levels for both the whole code readability aspects and each of the aspects. We also check whether consideration of code readability was affected by those programming levels. So these are our overall findings. Students basically tended to agree with our code readability statements. All of them scored no less than 3, which is neutral at least. Key 01, Key 03, and Key 08 were 3 questions with average responses score is higher than 4. Key 01 was about the readability of comments, and the issue might have been reported frequently. Students sometimes wrote unhelpful comments due to bad management of time. Some of them assumed that their unhelpful comments were still understandable by them later, which might be wrong. Further, CQIS encouraged them to read comments with words that are not listed in the dictionary. Key 03 was about readability of identifier names. So some students ran out of ideas for naming identifiers, resulting in meaningless names. CQIS reminded them about the matter by parsing the identifier names based on the transition style and pointing out words that are not listed in a dictionary. TO8 was about declaring and assigning only useful variables. Students sometimes had more variables than what they actually needed, and CQIS reminded them to remove unused variables. Key 07, Key 12, and Key 13 were three questions with the least accurate statement. Key 07 was about unused model imports, Key 12 was about too much code in a function, and Key 13 was about overly deep nested programming constructs. They rarely occurred on student submissions, especially at early programming levels like CS1 and CS2. Instructors are expected to focus on these aspects while informing students about code readability. Students occasionally considered code readability while completing their assessments. Half of them considered code readability after their code works at functional level. Nearly a third considered the matter while writing the code, and 7% always consider the matter, either while writing the code or after the code works. 15% did not consider such an aspect at all. So these students basically did not see the importance of code readability. Limited assessment marks were allocated to that matter, or maybe the students relied too much on automated formatting from their programming workspace. Most students provided their reasons for Key 15 as responses to Key 16. 90 of them are positive, so 46 were about to prevent readability issues in the future, so they might reread and reuse the code. 25 responses were about keeping the code simple, so some parts could be more effective and efficient. 19 responses were about to acknowledge that code readability is an important aspect in writing code. 63 responses were about why students did not fully consider code readability. So 31 of them considered code readability if it was part of assessment requirements. So basically, they only focused on short-term benefits. 25 of them considered code readability if it was seen achievable. They either forgot some code readability aspects or didn't have time to apply that due to bad time management. 7 responses argued that code readability was relative and depended on the programming style. Now we move to programming level findings, CS1 findings. The findings were somewhat consistent with overall findings, but student frequency of consideration of code readability is slightly lower. Why? Because for introductory level, being able to write readable code was not the main objective. The courses were more focused on encouraging students to be able to write working code, not readable code. Most of the students considered code readability, but the consideration usually happened after the code works. For CS2 findings, they are also similar, except that Key 06, Key 10, and Key 12 were the least agreed by CS2 students. Key 06 was about ensuring that each code line should contain only one program statement. Some students appear to believe that having two or more program statements in one line is still fine, as long as they are short statements. Key 10 was about having a reasonable number of Boolean operators in expressions or conditions, while Key 12 was about having reasonable amount of code in one function. These were seldom reported by CQIS as they were unlikely to happen at CS2 level. For advanced level findings, still it is similar to overall, except that Q04 was also a question with the most agreed statements. It was about consistent transition style for identifier names, like using either camel case or underscore as the separator. The importance of such consistency become more prevalent at advanced level. Key of 5 and key O9 were questions with the least agreed statements. Key of 5 was about not having too much code in one line, so they seldom occurred on advanced level since the courses encourage the use of programming workspace that automatically reformats code. Key O9 was about avoiding one-line branching, so such a branching was seldom used at advanced level due to difficulties in capturing complex expressions and long branching bodies. So the last thing that we want to discuss is about relationship between code readability awareness and programming level. So code readability awareness was generally improved for higher programming level, although it is not really substantial. However, when analyzed per questions, the improvement only applied to 7 of 14 questions. Other code readability aspects might be reduced on higher programming level. So, as I said before, as the programming level become higher, students considered code readability slightly more frequently. Key 15 agreement score was slightly improved from 3.7 to 3.9 and then 3.9. The slight improvement was partly since some students started to realize the importance of writing readable code. However, on advanced level, few students might ignore code readability as they believe the matter should be fixed automatically by IDE. Further, some identifier names were not freely defined by students. So as the conclusions, we evaluated the impact of employing an automated checker for code readability on student awareness of code readability for a year. The checker seems to generally help students understand code readability, especially on having clear comments and having only useful variables. Students occasionally check the quality of their code after they had ensured that the code worked at functional level. Of course, a few misconceptions might occur on higher programming level. Thank you.